Kleinrock, professor of computer science at UCLA, and I'm so happy to be able to honor and recognize Guglielmo Marconi's 150th birthday, along with all the other Marconi Fellows. In the 1890s, Marconi was among the great scientists who brought about wireless communications. It initiated a worldwide revolution: radio, wireless telegraphy, wireless communication in general. Was able to reach across the ocean in those early days with a small, inexpensive device and immediately transfer any picture, drawing, text, or speech seamlessly. That innovation, that technology development anticipated what we now call the internet. That vision for those early days just had to wait for the technology to catch up, which it did in the middle of this last century. That vision motivated me to devote my entire scientific career to help realize and launch the internet and all that lies beyond. In fact, the scene behind me is the birthplace of the internet here at UCLA. The impact on the global society is enormous and will continue to provide challenges, opportunities, and innovation breakthroughs as we move into the future. So once again, happy 150th birthday to you, Guglielmo Marconi.
Hello, my name is Vince Cerf. I'm the Chairman Emeritus of the Marconi Society. Some of us have been asked the question, what's going to be new in information and communication technologies over the next 5 years? Well, I admit that my ability to predict is not all that great. I'm the guy who thought 32 bits of IP address space ought to be enough for a while, and it turned out that wasn't true. But just looking at the next 5 years, you can see some immediate trends. First of all, a clear and rapid evolution of low Earth orbiting satellites as a way of offering communication to the internet and the applications that it supports. This has the prospect of being literally a global, every possible way connected system. But in addition to that, there's a great deal of investment being made now in increased subsea cable implementation, including north-south as well as east-west, in order to create increased resilience for this very important component of the global communication network. In addition to that, we're starting to see continued evolution of the Wi-Fi technologies, which we all know and love, typically using them at home and at work. But what's happened is that the specific implementations have moved far away from the original contention-based designs now into a more disciplined access, which will reduce latency and potentially also increase the capacity of Wi-Fi based systems. And of course, there's 4G, 5G, and 6G still to come. And those will increase our ability to use typically out-of-doors communication. Although I confess to you from time to time, a 5G hotspot has been a lifesaver in a building where I couldn't get access to the Wi-Fi. So those are some of the communication technologies that are important. Increasingly, by the way, laser-based communication, not only terrestrially, but also space to space in some of the low Earth orbiting satellite systems, and also ground to space and space to ground are also very likely to emerge in the next 5 year period, increasing bandwidth and making it possible for these systems to carry even more traffic than they can today. On the information processing side, the obvious thing, of course, is what's called artificial intelligence. And here the primary manifestations are in machine learning and specific kinds of machine learning, namely large language models. I don't want to over-focus or over-hype on those. The large language models are dramatic and fascinating and also don't always perform in the way that we expect. There's even a formal term called hallucination for the surprises that large language models sometimes produce in response to a prompt. But these are turning out to be very flexible and powerful tools for enhancing natural interaction, and certainly it's been very helpful for doing language transcription and language translation, something that is very beneficial when it comes to communicating on a global scale. So these are the near-term things that I believe will be quite common. Of course, I'm very excited about interplanetary communication. A network along those lines will emerge, certainly beginning in the next 5 years, and certainly evolve over the decades to come. Here, the protocol requirements are somewhat different from the terrestrial internet because of variable and very large delay and also disruption. So a new suite of protocols has been required. Those have been developed since 1998. They have reached a significant position of maturity, and they're likely to be used on the Artemis mission and LunaNet and Moonlight and some of the other projects that are aimed at cislunar space communication. So I hope that answers some of the question, but I'm sure that my colleagues will have even more insightful things to say.